but he was able to understand that the radius of the nucleus that is in the order of 10 to power minus 14, such a small, even smaller than point in size. So 10 to power minus 14 meter. That is what, and the other is radius of the atom. That is your in the order of 10 to power 10 to power minus 10 meter, correct? 10 to power minus 10 meter is 1 angstrom, right? So that is the size of the atom. We say radius of the atom means size of the atom. Okay, up to that is clear. Keep noting down, please.
Yes, sir.
Okay, so now he has done with the other material also, right? Gold he has taken, and then he has seen that, okay, few of the alpha particles are scattering through some angle, and most of them are going straight. Now he has changed the material from gold to silver, silver to platinum, and all, etc., whatever. So once he has taken silver, he found that, okay, now the scattering angle and the number of, and basically the number of alpha particle which has scattered is changing. That has given an idea that this is depending upon, it means that the scattering angle and the number of the alpha particle which has scattered is directly proportional to, he has concluded, it is charge square, the charge residing in the nucleus, and that is the positive charge, right? There is no question of charge. Charge is concentrated highly at the center of that, and that size of the nucleus, you see how small it is smaller than point in size rather. And then then other thing that from this experiment he understood, okay, that has to be, nucleus has to be positive, right? That's why it is coming back and the alpha particle are scattering, and other area it all electrons are empty, so that is not going to affect the alpha particle in any ways. It cannot, if it is positive, then only it is going to affect, right? So that is the observation he had. And now he has changed the material. And then he found that the number of alpha particle scattering and the angle is changing for different materials. And that he has concluded based on that, the quantity of charge within the nucleus is varying. It's not same for all the material. So you change the material, quantity of charge, positive charge into the nucleus is going to change. That is, he has concluded, right? So that is another achievement by the Rutherford. And so you can write that for different material, such as we can have, as for example, gold he has taken, maybe silver, maybe platinum, maybe anything, any metal, right, etc. He found that the angle, right, the angle and the number of alpha particle, this angle, will write that scattering angle, right? Scattering angle and the scattering angle and the number of alpha particle are different, right? So they may be your MCQ question. This kind of things are important for MCQ questions. So that has given the conclusion. From that, he has understood that this number of alpha particles scattered is directly proportional to charge square, charge inside the nucleus square. So conclusion was the number of alpha particle scattered is directly proportional to, mind it, this is directly proportional to, it is not alpha particle. So directly proportional to the square of, right, this is your square of the charge, and of course it has to be positive charge. So positive charge inside nucleus whole square, right? This is what he has concluded. So from here, they were able to make it okay that gold will have this much of positive charge at the center, and then the silver will have this much, platinum will have this much. That way they were able to classify all the metals after that experiment only, right? So it was open up. Up to Thomson, we were not knowing much about it was just an idea, okay, that we say like pumpkin, pumpkin, there is a seed also, and then, so entire solid and the seed can be considered as all atoms into that, and that kind of thinking was there of Thomson. But okay, that Rutherford started working on that. So somebody has started some way, and the other fellow is able to proceed further. Then after that, Bohr has come, who has done further experiment. So the things were quite open up about the atoms. So up to that, have you noted